Hello everyone, I'm Dr. Mehraei, and today we are going to run a hypothesis test using test-statistic, p-value, and confidence interval. So let's take a look at this example. Assume that the population has a normal distribution with a variance equal to 64. We take a sample with size 16 from this population and find out that mean and variance of the sample are 20 and 5 respectively. We are interested to estimate if the mean of the population is equal to 23 or not with 95% confidence level. Check this by running a hypothesis test using test statistic, p-value, and confidence interval. So there are different methods in order to run a hypothesis test. In order to do that, we should know about the cases that we have studied before. Please take a look at the lecture which we talked about confidence intervals. We explained about the cases in details. In the exam, for sure, you should know about how to make a z-score, t-score, so that we should know about the corresponding t-test and z-test, and also how to use central limit theorem in order to approximate it using standard normal distribution. For approximation of t-student and non-parametric methods, as I told you, I don't ask you in the exam to provide me the complete solution for them. In the exam, in case if it happens that we ask you about approximation of t-student and yes, approximation of t-student, not t-student itself. It actually is different for us. But approximation of t-student and non-parametric methods, in those cases, just tell us that this is the case, and we should mention that, for example, this hypothesis test can be run using approximation of t-test. That's it. Or this hypothesis test can be run using non-parametric methods. This is the final answer. You don't need to give me the answer in details in those two cases if it happens to be in your exam. Okay, so let's go through the question. How should I know which case we are talking about? Population has a normal distribution. Okay, this is a good news, but not good enough for us to right away say I should use z-score. It depends on my sample size and other things. Okay, so has a normal distribution with a variance equal to 64. This is a good news because I already have the variance of my population's value. This is 64. So I don't even care about sample size anymore. Right away, I can use normal, a standard normal distribution in order to find my z-score. And also the formula regarding confidence interval and everything can change through that. Even your z-test, the z-score that you find for it will change as well. Okay, so we took a sample with size 16 from it, so we don't care about the size of sample that much, if it's that big or not, and find out that mean and variance of the sample are 20 and 5 respectively. I have information about my population variance. I don't even care about this information about the variance of my sample anymore. Let's see. We will take a look at the solution. We will see whether we will use it or not, but this is not the case. We are interested to estimate if the mean of the population is equal to 23 or not. Okay, so first thing first, whenever we ask you about hypothesis testing, doesn't matter which case A, B, C we are talking about, we should construct our hypothesis. H0, null hypothesis, and HA, alternative hypothesis. We told you that we want to check whether mean of population, mu, is equal to 23 or not. The case of not equality, we prefer to put it on our alternative hypothesis, because at the end, as I told you in the lecture, we want to construct everything based on HA in terms of my graph, so that I understand where is related to rejection area, where this is related to acceptance area, then I decide based on that, okay? And in case if I say, for example, check if mean of population is greater than a number. In that case, it doesn't really matter whether you put it on HA or H0, because at the end you can reject one of them and know which one you accept. But usually in different books, they prefer that whatever they ask you, you put it as your alternative hypothesis. And H0 is the one that usually it claims to be, and it used to be claimed somehow, whether we accept it or not. Okay. So after that, first of all, we understood that this is a two-sided case because we have case of not equal. If it was more than or less than only, in that case, we call them one-sided case. Okay, so alpha, or type 1 error, is 1 minus my confidence level. It is given to us, 95% confidence level. So this is 5%. Next thing to do, Z0. What was 0 here? Because this is a Z-test. This is my test statistic. That's why instead of just saying Z, I use Z0. Okay. In order to find it, I should understand which formula I should use. That's why it was very important from the beginning of the example that I understood I have my sigma. I don't need my sample variance anymore. And here in the formula, I use the standard deviation, which is the square root of that. We should be careful for our calculation. And okay, so when we calculate this one, what is mu0, by the way? Mu0 is the number that you put inside your hypothesis test. Hypothesis, like for example, mu is equal to 23, mu is not equal to 23. We don't have two different numbers for them. In that case, we call this one the number that we want to check, mu0. So you see here, I don't have that information about mu. I should put mu0, which is 23. So I calculate this one, and we call it test statistic. How to run my test using test statistic though? Okay, take a look at this graph. How did I understand I should have two-sided case? Based on my alternative hypothesis is obvious, not equal to 23. It means that it's either more than or less than. So both sides I should be careful about. And you see, my alpha was 5%. And when we have two-sided case, my alpha would be divided on the right and left side of my graph. That's why I should calculate alpha over 2. So alpha over 2 is 25%. And I should know what is this number, this z-score here, and also this side, because I want to check my test statistic with these numbers. So I should check these two. You already know how to check them. And guys, please be careful whenever you write z inside the parentheses, a number. This one is the probability, the one inside the table, not on the margins. Okay, be careful about it. This is different from the one we said p, probability of z less than a z value. You see, they are different. Okay, so we should find out about both of the sides. As we said, this is happened to be 1.96, and this one minus 0.96. And be careful, you see, they are equal, just the sign of them are different. One of them positive, one of them negative. This one is easier for us to read from the table. As you know, the table I provide for you contains only from 50% positive z-scores, right? So find about this one first, and then you can find about this one easily. You see, you just change the sign. And this one is 1 minus this probability. This one is 1 minus this probability, you see? Okay, so how to check finally? I can check that my test statistic falls between these two numbers, you see, inside my acceptance area, not in my rejection area. If it was more than 1.96, we reject that hypothesis, null hypothesis. If it is less than 1.96, again, we should reject H0. So this one implies that we should accept H0, or there are not enough evidence to reject H0 with 95% confidence level. Okay, item B. How to check it using p-value. P-value is the probability. That's why we should check it with alpha itself. That's how we should compare it. Whenever your p-value is less than your alpha, type 1 error, in that case, you are allowed to reject H0 by using that specific confidence level. But whenever this is more than that, you are not allowed to do that. There are not enough evidence to reject H0. But how to calculate p-value? We should do it using test-statistic. Again, in order to find p-value, you should for sure calculate test-statistic. But in case of two-sided, we should remember that we should multiply it by 2, because on the picture it's obvious. We want to compare it at the same time with alpha. So alpha over 2 plus alpha over 2. For two-sided case, remember, we should multiply it by 2. In case of one-sided, there's no need to do that. We should just be careful whether we are comparing it with the right side or left side. And as we know, all of the probabilities are positive, so at the end, it doesn't even matter. So you don't need to multiply by 2 in case of one-sided case. Okay, so what does it mean? Z less than Z0, which is our test statistic. We already know about this value. What is that? Minus 1.5. In order to calculate it, as we know, whenever we have negative value here and we have less than, it's just good enough to write the complement of that because of the symmetric property of a standard normal distribution or any normal distribution that you know. Okay, so this value happens to be our p-value. Now let's compare it with our alpha. We see that p-value is more than our alpha. So there are not enough evidence to reject H0. So we accept H0 with 95% confidence level. Okay, the last one, we want to run the hypothesis test using confidence interval. It is possible, especially when we are dealing with two-sided cases. Equal, not equal. So you already know how to construct a confidence interval. We had it also in one of the tutorials. But let's see. Here I understood that this is Z. We already talked about it. And we understood we have sigma. We don't need our standard deviation of the sample. That's why we use this formula, not t-student, not standard deviation of the sample. So we already talked about these things, and you already know how to assign numbers to it. And now this part makes sense for you. That's why we use 1 minus alpha over 2. If it doesn't, again, please go through the lectures so that you know why we use 1 minus alpha over 2. Not, for example, 1 minus alpha here, or alpha over 2. And even if I use it, as I told you before, if I use alpha over 2 instead of 1 minus alpha over 2, my bigger value will be here. For intervals, we prefer to have the smaller value on the left side. That's why I use 1 minus alpha over 2. Anyway, since you know the formula, we don't need to think about it that much. But it's nice for you guys to know and know how to deal with the graph whenever we have such graph, so that we know exactly what happens in terms of test statistic, p-value, and confidence interval. Okay, assume that finally we found the confidence interval like this. If I want to check whether mean of my population is equal to 23 or not, I should check whether 23 falls inside this interval or not. I can see that 23 is between these two values. That implies that you can accept H0 with 95% confidence interval. If it was, for example, if I want to check for mu is equal to 25 or not, so I reject H0 with 95% in that scenario. So it was one important example regarding hypothesis testing. Please go through it again and again, but we need to consider all other cases as well. Please practice with them. There are some questions with solution inside your chapter 9, and also try to solve exercise at the end of the chapter 9 as well. Please consider all the possible cases, 5 different cases. 3 of them you should write the complete solution. For 2 of them, for approximation of t-student, not the t-student itself. This is just good enough to mention we should use that, or non-parametric method. You don't need to give the answer in details. Okay, guys, I hope it was useful for you. And by the way, don't forget to practice one-sided and two-sided as well. See you guys very soon.